So this session is really about whether or not technical debt is actually the real mine you're about to run into if you're looking at AI adoption at any point in the future. I think getting your ducks in a row around technical debt is really key to doing that. So welcome everyone. Thanks for joining us today. And then over the next 25 minutes, we're going to talk about one of the most expensive and extensive problems of enterprise IT. Excuse the alliteration. Uh, One that almost every organization has and almost nobody's fully solved. And that's getting significantly worse as AI enters the frame. I have a lot of planes here. I hope it's not interfering with the audio too much. But anyway, we're going to cover what technical debt actually is, why it keeps growing despite everyone knowing that it exists, and critically what it means for your AI roadmap in 2026. So on the agenda, next slide is what we'll cover. We've got 6 sessions, each building on the last, so they do actually make sense in sequence. We'll start with what technical debt actually is and why the original metaphor is still the most useful framing. Then we'll look at the types that do the most damage, because lumping them all together is part of why so many teams end up managing the wrong problem. From there, we'll get into data, the kind of numbers that make this hard to dismiss as a developer concern. Then we'll look at the structural reason it keeps growing, which is a governance issue more than a technical one. The AI section is where the urgency comes from in 2026, especially. And we'll close with 5 practices that organizations applying them are seeing real results from. So next slide. What is technical debt? And the next slide again. So this is actually a parable from the Old Testament of the Christian Bible, Corinthians 10:10, I think. And it's the parable of the dull axe. And I'm sure some of you will have heard it before. It is the perfect metaphor for technical debt. And it's sometimes framed around a woodcutter. So think of yourself as the woodcutter. And the idea is that he's so focused on chopping wood that he never pauses to sharpen his blade. So each swing becomes less effective. He works harder and harder, accomplishing less and less because he won't invest the time up front to maintain his tools. Sound familiar? That's really how technical debt works, isn't it? So you get caught up in delivering, you get so caught up in delivering that you skip the maintenance work and eventually you're grinding away at nothing. I think we all can relate to that. Next slide, please. So Ward Cunningham coined the term technical debt in 1992. The metaphor was deliberate and it's still the clearest way to explain it. He said that shipping imperfect code is like taking out a loan. A little financial debt speeds things up as long as you can pay it back. The problem is the interest. Every quarter, you don't just address it, it costs more. Every quarter you don't address it, it costs more and more to fix. And most technical teams don't pay it back. Most people encounter technical debt before they know what to call it. It's the feature that should take a week but takes a month. It's the code base that everyone apologizes for before opening. It's the system that works until it doesn't. The reasons are usually mundane. The proper solution takes longer than anybody wants to spend time on right now, so a quick fix ships instead. The system grows around it. By the time somebody wants to unpick it, it costs significantly more than doing it right in the first place would have, and that's the interest on your loan. And here's what makes it so persistent. The people who feel it most rarely control the roadmap. Developers face it every sprint, but the decision about what gets fixed sits somewhere else, so it persists. So what are the types that actually matter? Well, Martin Fowler mapped technical debt across 2 axes. The first was a deliberate or inadvertent. The second is, was it prudent or reckless? So that gives you 4 quadrants. You got prudent and deliberate. This is the acceptable version. A team knowingly ships something fragile to hit a deadline with a repayment plan already in mind. Somebody decided, somebody owns it. This is manageable. Then we have prudent and inadvertent in the top right. This is where a team realizes after the fact that the decision was suboptimal. They learn a better way. It's not ideal, but it's fixable, and you can refactor your way out of it. Then in the bottom left, we have reckless and deliberate, so no time for design, shortcuts taken without any consideration for what happens next, risky and harder to own up to, and owning up to is a responsibility is a really big part of this. And then reckless and inadvertent, and this is obviously the most dangerous one. Accumulated without awareness, no clear owner, no repayment plan, compounds silently, hardens into architecture and stops you from building anything new on top. So this is the unknown unknowns in the scenario. Most organizations are carrying all four types simultaneously, and there is a fifth category Fowler didn't include, which we call bit rot. Bit rot is really where code was perfectly fine at the time, but the systems around it have moved on and modernized. No mistake was made. The world just changed. You updated your stack, you pursued a best in class or a max strategy, for example, but a core element is now outdated and doesn't work well with newer systems. Next slide, please. That's the six types. And one AI created. So IBM identified five well-known categories of technical debt: code debt, legacy languages with shrinking developer communities; design debt, microservices that grow without clear ownership or consistent API standards or management; infrastructural debt, so say core banking systems running on decades-old mainframes with modern interfaces bolted on; test debt, which is automated systems deployed without proper coverage, proper testing; and then documentation debt, which is one that I think is a hidden one that lots of organizations suffer from. Undocumented integrations where the knowledge walks out the door when the developer does. And again, turnover and timing are a really key part of this. Who is and is not responsible for creating and fixing technical debt is really goes to the heart of it all. But we've added a sixth category that IBM doesn't cover, and that's context debt, which is bit rot essentially. It's particularly relevant in 2026 because AI is now part of the stack. So context debt occurs when AI tools operate on stale or superseded information. The output looks plausible, it reads as authoritative, but the underlying context is outdated and the damage is hard to detect until downstream work has already been built on false assumptions. So, akin to AI hallucinations, if the context that the AI operates in is not correct, then the outputs from the AI won't be correct. But knowing that is not easy to spot because you would have to know the subject area, you have to understand exactly what it's talking about first before you can spot what's wrong with it. So think about it this way. Code debt produces bugs that visibly break things. Context debt produces outputs that look correct but aren't. That's a harder problem. It erodes trust in AI tools, creates downstream rework, and is almost impossible to catch in a dashboard, for example. With AI moving from experimentation into production workloads, context debt is becoming the new infrastructure debt, the kind that seems invisible until it suddenly isn't. Next slide, please. So what's the real scale of the problem? Let's put some numbers on this. In 2025, a CAST report analyzed 10 billion lines of code across 47,000 applications in 17 countries. Their finding, global technical debt equals 61 billion workdays of repair time. Now, to put that in context, even if every developer in the world stopped building new things and worked on nothing else, it would take 9 years to clear the technical debt that we currently have. That's not a developer problem, that's a civilizational one, and it's growing. Closer to the enterprise reality, a 2025 Pegasystems study of over 500 IT decision makers found that a global enterprise wastes over $370 million a year with technical debt as a primary cause. Deloitte's 2026 Global Technology Leadership Study puts it at between 21 and 40% of annual IT spend going on maintenance, firefighting, and working around systems that were never properly finished. That's a significant drag on anybody's workload. For UK audiences specifically, the numbers are starker. The UK government's State of Digital Government Review, which was published in February this year, estimates that about 45 billion a year in productivity savings lost to outdated IT systems. Legacy systems now account for 28% of central government IT spend, so more than a quarter. And from Cloudhouse's State of the Technical Debt Report in 2025, 61% of UK organizations say legacy systems are actively blocking AI adoption. Only 36% have a fully funded modernization plan, despite 88% claiming to have a 2-year AI roadmap. Now, I don't know about you, but those numbers don't really add up. The ambition is there, but the reality doesn't stack up. Next slide, please. So why does it keep growing? It's the governance gap, really. It's not really so much a technical issue as a governance one. So if everyone knows this is a problem and the numbers are this stark, why does it keep growing? Why isn't anybody doing anything about it? Well, the answer isn't technical, it's structural. And the on-screen cycle shows that clearly. A developer raises technical debt as a sprint item. It gets acknowledged. It lands on the roadmap. Then a feature gets prioritized over it, and the debt item rolls to the next quarter. That quarter, the same thing happens, and the quarter after that, and the quarter after that. After enough repetitions, engineers just stop raising it. And it's rational that they do, because being the person who keeps pushing off technical debt becomes a professional risk in itself. You become the one who slows things down, so you stop. If you point at the problem, you are the problem. And I've certainly had that experience myself, so I do understand. This is how a manageable problem becomes the one that eventually lands on a senior leader's desk with slower delivery, rising costs, and no obvious place to start. The structural issue is this: the people who feel technical debt most intensely don't control the roadmap. Developers experience it in every sprint, but the decision about what gets prioritized sits with product managers, whose job is to prioritize features. And that's entirely correct. Their incentives point at delivery, not architecture. But without someone accountable for the architectural view across programs, not inside a single team, but across all of them, debt accumulates by default. Debt by default. Nobody's doing anything wrong. The governance structure doesn't provide a reason to address it. The Software Engineering Institute has argued for cross-program governance of technical debt, specifically for this reason. Someone inside the individual team needs to own it, track it, and be accountable when it isn't addressed. Leaving it inside the team is precisely how it stays invisible. Next slide, please. So there are three misconceptions listed here that keep technical debt off the leadership agenda. They're all plausible, but none of them are true. Firstly, it's an engineering problem. This is the most damaging because it steers the conversation towards the wrong person. In organizations that rely on system integrators or contractors, the people who introduce the debt won't be there when the problems surface. And that's often true of internal staff as well. Their incentives end at handover. The debt that follows is simply what happens when nobody building the system has any reason to care about what it will look like in 3 years' time. That is a structural and procurement issue, not a code review issue. Secondly, that it's the results of bad engineering. Well, that framing turns a structural problem into a blame conversation, and blame conversations are very hard to make progress on. Most technical debt comes from reasonable decisions made under real constraints. A team who chose the quick solution because the timeline was real and the alternative wasn't viable. Treating that as a failure of an engineering team is one of the main reasons it doesn't get addressed early enough. The people who could fix it feel defensive rather than heard. And finally, we can ignore it as long as we keep shipping. Delivery speed hides the cost for a while, but each quarter, a little more engineering time goes to maintenance. Each roadmap cycle, something gets deprioritized to keep the existing systems running. It's holding on to a rising balloon, really. The budget doesn't shrink on paper, but as more resources are dedicated over time to maintenance, the leftover capacity does. So by the time leadership is asking why delivery has slowed, the debt has usually been compounding for 2 or 3 years. So this is the sharpen your axe argument. Next slide, please. Technical debt is your AI adoption risk, and this is really where the rubber hits the road, I think, for most of us, because AI adoption is forcing the issue on technical debt. This is where the stakes change this year. Most AI roadmaps right now are built around implementation, which tools to adopt which use cases to prioritize, what the timeline looks like. Very little emphasis on the foundations on which those tools will land. And that's where the gap opens up. AI lands on whatever's already there. It doesn't fix foundations, it amplifies whatever exists already. So whatever problems you have, AI will amplify them. It might amplify your productivity, but would also amplify your problems. Which means if your infrastructure has problems, AI will surface those problems faster than it solves them. The data backs this up. IBM projects AI's share of IT spending rising from 11 to 18% in the next few years. I think that's pretty conservative myself. 61% of organizations say legacy systems are actively blocking AI adoption, and organizations that launch AI initiatives on top of unaddressed technical debt tend to find out the hard way that significant rework is required, typically 12 to 18 months. That's not a prediction, it's a pattern. Liferay has seen this across multiple clients in the last 12 months. The right side of this slide clearly shows the choice. Without debt reduction, AI amplifies existing problems, initiatives stall before value ships, then comes the expensive remediation that should have happened first. With technical debt reduction as part of the roadmap, clean APIs, modern architecture, AI integrations that actually ship, lasting value from the investment rather than a cycle of rework. The reframe we'd encourage is this: debt reduction is not a parallel work stream. It is not something you come back to once AI is live. It is part of the AI investment, the infrastructure that makes it worthwhile. Next slide, please. So the returns on paying down this debt. Well, let's talk about the upside, because paying down technical debt isn't just a risk mitigation. The returns show up in areas that leadership already tracks. Faster delivery. Everyone wants faster delivery. McKinsey found that companies addressing technical debt systematically achieve 20 to 40% productivity gains in software development. Less complexity means fewer things to work around every time something new ships. That's not an estimate, it's what's measurable. Once teams aren't spending the majority of their sprint capacity on maintenance, and compliance risk drops. Cloud House's 2025 survey of 250 UK IT leaders found that 48% had already encountered compliance failures during audits, specifically because of outdated infrastructure. Newer, cleaner systems are easier to evidence, easier to map, and present a much smaller surface area for auditors to find problems with. That's a direct reduction in exposure. And the one we all want, AI becomes viable. We've covered this, but the number is worth repeating. 61% of UK organizations reported that legacy systems are blocking AI adoption and are facing a plumbing problem, not an AI strategy problem. We got to clean the pipes first in order to achieve this. If you want AI to deliver on its promise, then this underlying work really needs to be done first. And finally, lowering the total cost, which is another thing everyone wants. Deloitte's 2026 study puts between 21 and 40% of the IT budget towards maintenance. That's 40% of your IT budget being spent on maintenance, firefighting and working around systems that never properly finished. That's a budget that could be funding AI. New products are simply just shipping faster. A landlord who skips repairs doesn't save money. The damage accumulates until the fixes become structural. Next slide, please. So let's just have a quick run through really what the 5 strategies and good work practices or best practices in this regard are, just to sort of give us a bit of optimism, and certainly something that we have seen in with numerous customers over the last 12 to 18 months, but especially the last 12 months and even more so the last 6. But 5 practices that distinguish organizations that manage technical debt well. And they're not occasional initiatives, they're really structural commitments. So, firstly, make it visible. If it's invisible, it doesn't get addressed. Technical debt won't announce itself. Feature flags are a clean example. Useful in the moment, but in project-driven environments, the PM who ordered them has moved on long before anyone budgets to remove them. A tech debt registry that tracks and prioritizes debt um, alongside new features makes it real in a way that sprint planning conversations rarely do. Code reviews, automated testing, and CI pipelines that track performance regressions as they happen, rather than after release as they're shipped. All catch accidental debt before it compounds. Number 2, name an owner. In large organizations, change spans multiple systems, and no single project can contain it. Each team picks whatever gets their work finished. Nobody owns the view across all of them, and the architecture pays for it. The SEI's argument for cross-program governance is the right answer. Someone outside the individual team needs to own it and have the authority to act on it. 3, as we are often accused in if you're on a technical team, we need to frame things in business terms. Delivery speed, compliance exposure, support, overhead. Put it in those terms and it lands on the right desk with the budget to act on it. A technical debt registry phrased in engineering terms stays in the engineering team. One that connects to business business outcomes, gets visibility. Number 4, dedicate some time to it. Shopify dedicates 25% of all development cycles to managing technical debt. running dedicated debt sprints alongside feature delivery. That's not an accident and it's not optional. It's a deliberate commitment. Test-driven development prevents unintentional debt from accumulating in the first place. And five, treat it as part of the roadmap, not a deferred to a sprint that never happens, not a parallel work stream that never gets resourced. Alongside features with the same discipline, the organizations that handle debt well have stopped assuming someone else is keeping track. So see it, name it, give it to somebody to have ownership of it, then build it into the product development cycle as a standard part of your day-to-day work. Not don't see it as an additional remedial set of actions that you need to take at some later unspecified point. Next slide, please. So how Liferay DXP addresses technical debt. So most platforms add capability on top of whatever's already there. Liferay DXP is built to sort of replace the underlying structure where the debt actually lives. Firstly, platform consolidation means that fragmented systems that were never designed to interact are integrated with a single governed platform. So the engagement layer, less to maintain, fewer points of failure, fewer places for debt to hide. Secondly, modularity and reusability mean development teams stop rebuilding the same things from scratch. Pre-built components reduce the amount of custom code and lower long-term maintenance costs. Then there's the upgrade-friendly architecture, and that matters because upgrades on legacy systems are often where architecture debt compounds fastest. Every major version becomes a migration project. Liferay's approach keeps that manageable. And then you have AI-ready foundations, meaning clean APIs, modern architecture, so the AI integrations ship rather than stall. No expensive remediation layer required before value lands. A real example of this is the Building Research Establishment, or BRE, the UK's #1 billing research entity. They had 81 sites spread across multiple platforms. They're a Liferay customer. Security risks were growing. IT teams are stretched. After moving to Liferay DXP, they reduced those 81 sites down to 9. That's an 88% reduction in digital footprint, and the corresponding operational costs came down very significantly. Content teams became self-sufficient. The technical debt wasn't just in the code, it was in the structure, and that's really what changed. Next slide, please. So we got 3 questions for your organization. They're all rhetorical, obviously, but diagnostic. First, can your platform take on new AI tools without significant rework? If the answer is I need to check, that's effectively no, really. Clean readiness for AI integration is a binary. The foundations either support it or they don't. If the answer requires investigation, it's likely that they don't. Secondly, do your teams spend more time maintaining what's already there than shipping what's next? If more than half of your IT time and spend is expended on technical debt, then you really need to stop and take a beat, so to speak. If engineering time on maintenance is rising quarter on quarter, the debt is compounding, and delivery speed might be masking this because it often does. But the proportion of time going into firefighting versus building tells you where the trajectory is headed. And then lastly, when debt surfaces, it's something you planned for or it's an accident. Planned debt has an owner and a repayment timeline. Incident debt has a post-mortem. If most of your debt conversations occur in response to a breakdown rather than during the planning cycle, the governance structure needs attention. So if you talk about debt before delivery, you're doing it right. And if you talk about debt after delivery, then you're just reacting. And if any or all of those sit uncomfortably, that's where your work starts. And finally, the last slide, the key takeaways and call to action. So I got 5 things to take away. Just a quick recap of everything that I've sort of covered in the last 25 minutes. So technical debt belongs on the business agenda with a named owner and a funded plan, not on an engineering backlog. If it's there, then it's never going to work. And certainly if you try and deploy AI on it, that will be a painful experience. Because secondly, AI amplifies weak foundations as fast as it amplifies capabilities and productivity. Debt reduction is part of the AI investment, not a prerequisite or separate program that you defer. It's a fundamental part of any AI program. The people who feel tech debt most rarely control the roadmap, which is what we were talking about earlier. The technical people don't control the roadmap necessarily, and the people who really notice are in the business side of the business. Governance really is the fix for that. And might seem obvious, but debt that's visible and owned gets addressed. And obviously, debt that is invisible and isn't owned doesn't get addressed. Debt that grow that isn't sorry, debt that isn't just grows, absorbing capacity that was supposed to go elsewhere. And finally, progressive investment in reducing debt consistently beats trying to solve it all at once. So a sort of a boil the ocean approach where you're trying to do all of it at one go. I think there are two drawbacks to that. Firstly, that if you do it that way, then it will all come up for renewal at the same time again. And actually, what you need to be thinking about is that technical debt is built into your everyday work, that it's a percentage or a part of your ongoing everyday development cycle. So Shopify, what, 25% of every single sprint goes to technical debt reduction. I think that's a good baseline to sort of begin with. So finally, I'd like to say, remember to stop and sharpen your axe from time to time. That's absolutely vital. So thank you for your time today. If anything we've covered resonates with your situation, we'd genuinely like to talk it through with you. There's a link for the demos on screen, and we're happy to take questions now.
There we go. Thank you, Mike. That was a really good session, really insightful. We have just run out of time to run through any questions. So any questions that you have had, we've collected those and we will answer those directly after the session's finished. They will be followed up through email. And for now, I think that's it. We'll keep you updated with the next session that comes along in the next couple of months.